Ionic product of water. This is today's lesson. In this lesson, we are going to learn derivation of equation of ionic product of water and what is autoionization or self-ionization of water. So, let's begin. In the year 1894, scientists Kohlraasch and Wheeler proved that very pure water conducts electricity to a very small amount. That is, water is a kind of weak electrolyte. The reason is that water undergoes self-ionization or auto-ionization to a very little amount. Let's see self-ionization of water molecule. This is water molecule which acts as weak electrolyte. That is why very little amount of water ionizes to proton and hydroxide ion. This ionization of water is known as auto-ionization or self-ionization. As water is a kind of weak electrolyte, equilibrium state exists in this reaction. Let's write the reaction according to law of mass action. Equilibrium constant K is equal to, according to law of mass action, we can write concentration of proton times concentration of hydroxide ion divided by concentration of unionized water. In this reaction, water acts as amphoteric substance. According to Arrhenius' ionic concept, the substance that can donate proton is a kind of acid, and at the same time, the substance that can donate hydroxide ion is a kind of base. So in this reaction, water acts as amphoteric substance according to Arrhenius' ionic concept. Let's go to the equation. By cross multiplication, we can write K into concentration of unionized water is equal to concentration of proton times concentration of hydroxide ion. As we know, water is a kind of weak electrolyte. That is why a very little amount of water ionizes to hydrogen ion and hydroxide ion. But this ionization is extremely little. That is why concentration of water is considered constant. Then we can write this is constant term. If concentration is considered constant, then we can write a new constant Kw. Here W stands for water. Now concentration of proton times concentration of hydroxide ion. Here Kw is called ionic product of water. After ionization of water, hydrogen ion and hydroxide ion are obtained as product of the water. So this is the product of the ions of water. That is why it is called ionic product of water. So Kw is known as ionic product of water. The value of Kw changes with the change of temperature. At 25 degrees Celsius temperature, its value is 10 to the power minus 14 mole square per liter square. This is ionic product of water. As we know, water acts as amphoteric substance according to Arrhenius ionic concept. Let's see amphoteric nature of water according to Bronsted-Lowry protonic concept. The concept is the compound that can donate proton is an acid, and the compound that can accept proton is a kind of base. Now let's see amphoteric nature of water according to Bronsted-Lowry protonic concept, and at the same time let's determine ionic product of water according to ionization of water following Bronsted-Lowry protonic concept. According to Bronsted-Lowry protonic concept, acid is proton donor and base is proton acceptor. Let's see amphoteric nature of water according to Bronsted-Lowry protonic concept. One molecule of water. Let's write another molecule of water. If this water acts as acid, then it donates proton. If it acts as base, then it will accept that proton. Now let's write the equation, that is, after donating proton, this water becomes hydroxide ion, and after receiving proton, this water becomes hydronium ion. As it's a reversible reaction, equilibrium constant K is equal to, according to law of mass action, we can write concentration of hydroxide ion times concentration of hydronium ion divided by concentration of water. Here actually two molecules of water participate in the reaction, so we can write here two molecules of water. These two will be here as power. Now after cross multiplication we can write equilibrium constant K times concentration of water, 2 is as power, is equal to concentration of hydroxide ion times concentration of hydronium ion. As we know, water acts as weak acid and weak base. The amount of water participated in the reaction is extremely small. That is why concentration of water is considered constant. Then this is constant, this is constant. A new constant is used, which is Kw. This is actually ionic product of water. Kw is equal to concentration of hydronium ion times concentration of hydroxide ion. According to Bronsted-Lowry protonic concept, Kw is equal to concentration of hydronium ion times concentration of hydroxide ion. This is ionic product of water. No more today. Thank you very much.